Hello everybody, welcome to your video notes. This is Mr. Basil and let's get started. So this is learning target 4.3 at the meets level, which is the question that we're trying to answer in this video is what are the common ions and how are they formed? In the previous video, we talked about how to make Bohr models for neutral atoms and how to do Lewis structures for them as well. So you should know how to do that before watching this video. If you don't, go back and watch the previous video. And then we will get going here. So the first thing that you need to know, well, the first question that we're going to answer is how are common ions formed? And we kind of answered this in a previous video, but here it is again, in case you need it. So here it is. Atoms gain or lose electrons in order to form a more stable configuration. And in order to do this, they're going to follow a rule that's known as the octet rule. Okay, the octet rule just says that atoms have a tendency to prefer full valence level of electrons. Okay, and as you're going to see in these upcoming examples, you're either going to gain electrons or you're going to lose electrons depending upon what is, quote, easier. So let's go over to these three examples that we went over in the last video for hydrogen, lithium, and sodium. These are these three elements on the periodic table. And one thing you might remember from last time is they all have one valence electron. Even though they have different energy levels, you know, like hydrogen has one energy level, lithium has two, sodium has three. What we're really focusing on here are the valence electrons, okay? So each atom is going to try to get a, quote, full valence shell, okay? And let's start by looking at lithium. In order to have a full shell here, you'd need 8 total, or full level here, you'd need 8 total electrons. Now, lithium can either do that by losing one, having that one go away, or it can gain 8. You can either lose one electron, and then it would have a full valence shell here, and remember that first level only needs 2. Or it could gain 7, so 1, 2, 3, 4, 5, 6, 7. What's easier? Losing 1 or gaining 7. It's going to lose 1 electron here. And then it would have a full valence level there. For sodium, it's going to be the same thing. It could lose 1 electron, because if this 1 electron went away, then we'd have that full shell that's underneath. Or it could gain 7 electrons. Well, again, it's going to lose 1 electron because that's a lot easier to do than gaining 7, okay? And whenever we're doing this, you always have to ask yourself, what's easier? Losing this many or gaining this many to have a full shell? So then let's look at fluorine here. My keyboard keeps popping up. That's silly. Okay, so fluorine now. Notice that this one has 1, 2, 3, 4, 5, 6, 7. So fluorine's choice is it could lose 7 electrons or gain 1 electron. So in this case, it's going to gain 1 electron because that's a lot easier, right? It's going to take a lot more energy, a lot more work to get rid of these 7 electrons than to just have 1 more come in to give that full 8. Okay? Now, whenever you're doing this, you're basically just going to look at, well, which number is smaller? That's going to be easier. Pardon the bell. But for elements like silicon, where you have 4 valence electrons, the question is, well, I need to get to 8 here, and I could either do that by adding 4, or I could take away 4, because if I took away 4, then that valence shell becomes the second energy level. So am I going to gain 4 electrons or lose 4 electrons? And so whenever we end up with this, the numbers are the same. So, well, which is it? Either one. Okay, either one is equally likely when you have gain or lose 4. Okay, and so there we have it. Now let's just talk, because you know this is all fine and all, but we can actually use the periodic table to help predict this, just like we can to help predict how many valence electrons we have. Because if you remember in the previous video, you know, I told you we're gonna skip these. Skip the transition metals. But group 1 has 1 valence electron, 2 valence electrons, and so on. 3, 4, 5, 6, 7, and 8, with the exception of helium. That's 2 valence electrons, right? So that's just a review of before. Well, if you notice, if you have 1 valence electron, let me switch colors here. So if you have 1 valence electron, you could either, you know, just like these ones, you could either lose 1 or gain 7 to achieve that full valence shell. And so what you end up doing for each of these, it follows a pattern here, right? You could lose 1. Well, yeah, you're going to lose 1. In this one, you're going to lose 2. And then we skip the transition metals. Over here, you're going to lose 3. Here, it's going to be plus or minus 4. Then here, you're going to gain. So this one, you have 5, so you need to gain 3. And here, you're going to gain 2. Here, you're going to gain 1. This one, you're not going to gain or lose any. All right? Now, because of this, let's go back to these here. If you lose an electron, you're losing negative charge. So if you lose a negative, this becomes a positive 1 ion. This also becomes a positive 1 ion. Okay? Because you're losing that negative charge, you now have 1 more proton than electrons. It now is a plus 1 ion. So it's kind of opposite, right? You're losing an electron, so you're gaining charge. It's kind of opposite. So it's a little confusing sometimes, but just got to know that somehow. Here, you're gaining an electron. So in this case, it becomes a minus 1 ion. Okay? You're gaining an electron, so it becomes negatively charged. And then here, if you gain 4 electrons, that's going to become a minus 4 ion. Or if you lose 4 electrons, then it's going to become a positive 4 ion. All right? And so, because of that, I'm going to erase all of this here. You can use your periodic table to help with this as well. And I want you to actually write this at the top of your periodic table, if you have one. So all of the group 1 elements are going to form plus 1. Let's change the size of that one. These are going to be plus 1 ions. These are going to become plus 2 ions. Let me skip all these guys. Come over here, plus 3 ions. This could be plus 4 or minus 4 ion. This one's going to become nitrogen's column, 15, is going to be a minus 3 ion, minus 2 ion, minus 1 ion. And then these ones are not going to form ions, so no ions in this column. Okay? Because again, fluorine is just going to gain one ion, or one electron to become -1 charge. Oxygen is going to gain 2 electrons to become negatively charged, and so on. So I'm going to be ending the video after this, but here's just another way that you can think about this. So here, it's a modified periodic table. So this is where the transition metals are. Okay, I just took those out and put these together so that way you could see things a little bit better. So again, these are going to become a -1, -2, -3, plus or -4. Oops, positive, -3, -2, -1, and then nothing. Okay, and the reason again is because this electron goes away. This electron goes away. These 2 electrons, those go away. So then you're left with +2 charge. And we can see that's true for everything in the column. Magnesium has 2 valence electrons, so those go away. And then we can come over here to, let's say, oxygen. Oxygen has 1, 2, 3, 4, 5, 6 electrons. So that one is going to have 2 electrons come in. And when those 2 electrons come in, that's what gives us a -2 charge. For nitrogen, we have 1, 2, 3, 4, 5 electrons, and so I need to add 3 electrons in order for this to become a -3 charge. Okay? Alright, thanks for listening, and see you next time.